In this video, we're going to solve a variety of linear equations. We're going to look at some pretty complicated linear equations with fractions in them. If the problems were less complicated, you would typically apply inverse operations to solve for x. So typically you'd add or subtract first, then multiply or divide, so on and so forth, to isolate x. Our goal is to isolate x as well, but since there's going to be some fractions in the mix, what we'll do is we'll multiply by the least common divisor. So in this problem, we have a linear equation, x is to the first power. And what we're going to do is we're going to try to get rid of these darn fractions. So we're dividing by 3, dividing by 2, and dividing by 6. So what we'll do is we'll find the least common divisor. Find the smallest number that goes into 3, 2, and 6. So if someone counted by 3s, and someone counted by 2s, and someone counted by 6s, the first number that they would all hit on is 6. 3, 6, 2, 4, 6, and then 6, 12, 18. The first number they hit on is 6. So what we're going to do is we're going to do the inverse of division, which is multiplication. We're going to multiply both sides of the equation by 6. So, why would we do such a thing? Well, the inverse of division is multiplication, and since we found the least common divisor of each and every single one of the denominators, by the way, 2 is just 2 over 1, so that doesn't really change anything, but it's important to realize that 2 is 2 divided by 1. Now what we're going to do is we're going to multiply each part, because we have the distributive property here. We have multiplication over subtraction, and we have multiplication over addition. So we're going to distribute. Now, the 6 will get multiplied by the 2/3 x, and the negative 2 will also be multiplied by 6. So that's the action of distributing. Similarly, the 6 will be multiplied by 3/2 x, and the 1/6 is also multiplied by 6. So the 6 was distributed everywhere. Now, here's the interesting part. We now are multiplying some fractions out here. Now, you could kind of clean this up a couple of different ways, but the way I really tend to think about it is I like to divide first. 6 divided by 3, 6 divided by 2, and 6 divided by 6. Each one of the numbers, each one of the fractions really that I circled, 6 divided by 3, 6 divided by 2, and 6 divided by 6, they're all going to make whole numbers. That's the advantage or the benefit of multiplying by the LCD. So 6 divided by 3 makes 2. 6 divided by 2 makes 3. 6 divided by 6 makes 1. And everything else is just going to stay the same. We still have a 2x here. We have minus 12. We have a 3x remaining here. And we just have a plus 1. So each of the circled portions, 6 divided by 3 made 2, 6 divided by 2 made 3, and 6 divided by 6 made 1. Now we can just multiply. We have 4x minus 12 equals 9x plus 1. And now we just have, a normal looking, if you will, a linear equation without any fractions. So from here, we can just isolate x, meaning the inverse of positive 4x is negative 4x. So we can subtract 4x from both sides. And if we bring our x's to the right, We'll bring our numbers to the left. The inverse of plus 1 is minus 1, so now I have negative 13. That equals 5x. The inverse of multiplication is division. Divide negative 13 by 5. Divide 5x by 5. 5 divided by 5 is 1, times x is x. And boom, we have our final answer. And what's nice is we can check this problem. I'll leave that as an exercise for you to make sure that you're feeling comfortable and confident with fractions. But it's really nice in this course that everything you do, you can in fact check your answers, plug them in, and make sure that you are in fact correct. So our first demo problem here is pretty similar to our motivating example. We have some fractions, and we don't love division. We'd prefer not to, but the inverse of division is multiplication. So what we're going to do is we're going to find the LCD, least common divisor, of each one of the denominators. So if someone counted by 4s and 2s and 6s, the first number they would hit on is in fact 12. So we'll multiply both sides of the equation by 12. Now notice the use of parentheses. I didn't make a big enough deal in the last example here, but what we're going to do is we're going to multiply both sides by 12. The parentheses show that we're grouping. We're taking the entire left-hand side of the equation, multiplying by 12. Similarly, we're taking the entire right-hand side and multiplying by 12. And this will help remind us that we do, in fact, need to distribute on the left-hand side. Now, what's nice is, since we found the LCD, we can divide. Well, let's actually not. So don't go too fast because you might forget to distribute. So hold on. Let's actually write this out. We have 12 multiplied by 3/4 x with the distributive property. And the negative 7 halves is also multiplied by 12. Over here, we have 12 multiplied by 5/6. Now, what I did in the last problem was I did the division first. I think that's kind of nice because it makes numbers smaller faster. So 12 divided by 4 is 3, times by 3x. The negative 7 is multiplied by 12 divided by 2, which is 6. 12 divided by 6 is 2. And then we're just multiplying by 5. Now, again, this looks very similar to the last problem once we cleaned it up and got rid of all the fractions. Now we have 9x minus 42 equals 10. Now this is a good old two-step linear equation. We want to get x by itself. The inverse of subtraction is addition. We'll add 42 to both sides, so we have 9x equals 52. The inverse of multiplication by 9 is division by 9. And our final answer is x equals 52/9. This second example here, what we're going to do, typically we multiply by the LCD at first, but here, since we have multiplication, the entire left-hand side is being grouped together and multiplied by 3/2, I'm going to recommend that we multiply this out first, meaning distribute to 3/2. 3/2 is going to be multiplied by 5/9 x, and the 3/2 is going to be multiplied by 4/27. Notice how the 3/2 is not multiplied by the 3. In this problem, only 3/2 is multiplied by the left-hand side. The right-hand side just kind of is as is. So now, recall when we're multiplying fractions, multiply the numerators together, we multiply the denominators together. So here we have 3 times 5x, that's 15x in the numerator. 2 times 9, that's 18 in the denominator. 3 times 4 is 12. 2 times 27 is 54. And that equals 3. Now, we have reduced this problem to looking like the previous problem, or the previous two problems. So now we'll just get the LCD. of 18, 54, and 1. 3 times 18 is 54, so 54 is going to be our LCD, our least common divisor. So I'll multiply both sides by 54 by 54. Recall we know 54 divided by 18 is 3. Oh, again, now I get so excited to do this, but it's actually good to model this because this is sometimes what students do. First, make sure that you distribute so that you don't forget that that 54 is going to go to both of these parts. So just be careful. Apparently I really want to do that. So it's actually good that I'm modeling that and catching myself, because you need to know what sort of mistakes you're going to make so that you don't make them. So 54 is being multiplied by both terms on the left-hand side. And on the right-hand side we have 54 by 3, that's 162. So now we're ready. 54 divided by 18 is 3. 54 divided by 54 is 1. Times 12 makes 12. So now we have a nice two-step linear equation. 45x equals 162. From here you should be able to solve this. Subtract 12 from both sides, divide by 45, you'll have x isolated by itself. In our final demo or discussion problem, I'm just going to get you started. But this is sort of similar to question number 2, the demo discussion problem that we did previously, but it's a little bit more complicated. So let's kind of get the ball rolling here. Similar to question number 2, we should distribute first. So the left-hand side is unchanged. We have 3/4 x minus a half. Now be very careful. You got to make sure you understand that x is actually in the numerator. And then we have 1/3 times 3/4. 1 times 3 is 3. 3 times 4 is 12. This is 3/12 x. So I kind of put it along the side so that we know that it's in the numerator a little better. Be careful. Make sure you're saying what you mean to say and writing what you mean to say. 6 times 1 is 6. And 6 divided by 1 is 6. So the denominator, 3 times 1 is 3. Then we have a 7 halves here. So now we need to find the LCD of 4, 2, 12, 3, and 2. The LCD in this problem is going to be 12. If you count by 2s, 3s, 4s, and 12s, the first number you're going to hit on is 12. So now you're going to multiply every single piece or part by 12. I'll give you an opportunity to clean it up, but once you do this enough, you'll start to just sort of feel more comfortable and fluid with the process. So in my head I'm saying 12 divided by 4 is 3 times 3x. Well, that just makes 9x. And similarly, 12 divided by 2 is 6. Multiplied by -1, we have -6 over here. Got to make sure we distribute. That's huge. 12 over 12 is 1 times 3 is 3 times x is 3x. 12 divided by 3 is 4. Times 6 is 24. 12 divided by 2 is 6, times -7 is -42. And then from here, you're going to clean things up. You'll get 6x equals -12. All in all, you'll get x equals -2 in this problem. And then you should be able to plug in everywhere there was an x in the original problem to verify that you're correct. So just as a general rule of thumb, if there is any distributing to do in a problem, make sure you distribute it first, combine like terms, then from there you're typically going to add or subtract. then multiply or divide, and your ultimate goal is to solve for, as in isolate x. That is the name of the game.